All right, ladies and gentlemen, so today let's talk about lesson 9.1, which is graphing quadratics using the vertex. Skills we're working on. The first skill is that idea of interpreting and sketching the key features of graphs, and then the other one is graphing quadratic functions. When we get started with this, we have no new terms yet, but we are going to add one in today, or more importantly, we're going to refine a term that we have defined before. So what we're going to do with this little intro problem here, we want to graph by factoring to find the root. So graph the way that we know how to do it, which means that I need to find terms that multiply to make 15 and add up to make 5. There's no leading coefficient to factor out. So this is what I'm left with here. But if I run through all of my sets to get to 15, I know it's positive and positive, so I can have 1 and 15 or 3 and 5. But neither of those sets are going to add up to give me 5. So I'm stuck. Using my skills, I can't factor this. And the reason that happens is if I plug this into Desmos, my graph looks like this. I don't have any roots. That quadratic does not cross the x-axis, so there's no x's, no zeros to find here. So I need to come up with a new skill. So to come up with that new skill, I'm going to go back to skills that I know and figure out what I can pull out if there's a general formula, and there is, to find that vertex every time. So if I look at this first sample here, these ones should be in your notebook now, I have y equals negative 2x squared plus 5. So the first thing I want to do is I want to use my factoring skills, and in this case, it's a greatest common factor, and I can pull an x out of both of these pieces. When I do that, I'm left with x multiplied by negative 2x plus 5. So I know that my roots, that zero product property tells me that either x is equal to 0 or negative 2x plus 5 is equal to 0. So now that I'm looking at it, my roots here are either going to be 0 for that first one, or with my second one, it could be negative 2x plus 5 equals 0. If I take away 5 from both sides, I get negative 2x equals 5, x equals 5 over 2 negative. So negative 2.5. So I have two possible roots here. So now I want to find my vertex, like always. I want to find the x value of my vertex so I can set up that axis of symmetry. I know my axis of symmetry is whatever my x value for my vertex equals. So I have x equals whatever that term is, and that gives me that vertical line through the vertex. So to do that, I need to find the halfway point. I'm going to take 0 plus negative 5 halves, and I'm going to divide it by 2. Again, I'm just finding the halfway point of those roots. When I do that, I get, well, negative 5 halves over 2. If I want to simplify my fraction, negative 5 halves over 2, I know to do that. That's the same thing as saying negative 5 halves divided by 2, which I know with my fractions divided by 2 is the same thing as multiplied by 1/2. So using my fraction rules, I know that the x value of my vertex is located at negative 5/4, or negative 1.25. Now to find the y value for my vertex, I would go back and plug it into my original equation, and I should find out that the y value is 9.375. Plugging and chugging to go back through. But the part that I really care about is this axis of symmetry. When I have this piece here, now let's go and think about it in variable terms. If I go back to my generic quadratic formula, y equals ax squared plus bx plus c, but we'll get there in a minute, I need to figure out how I can find that axis of symmetry, that x value for my vertex. So we're going to go through the same process. The first thing I can do is I can factor out that x. I'm using that greatest common factor method of factoring to find my roots, and I get this here. So now what I'm going to do is, that was a negative, I get y, my roots here are going to be either x equals 0 or ax plus b equals 0. If ax plus b equals 0, I need to use my two-step equation rules, and I get ax equals negative b. If I divide both sides by a, I get that x value is negative b over a. Now to find the x value for my vertex, I'm going to find the halfway point between 0 and negative b over a. Using those same rules of fractions that I used over here, I can find out that the x value for my vertex every time is going to equal negative b over 2a. And this is a really big idea, so we're going to refine our definition of the vertex. So let's finish it off, and we're going to take our vocab here. We're going to refine that definition of the vertex using the skills that we just learned here, that we can define the vertex no matter what, using that generic formula. The vertex is equal to negative b over 2a every time. So in your notes, please write down this entire vocab definition. When we're talking about the x-coordinate of the vertex, we have that it will always be located at negative b over 2a, which means that our axis of symmetry is the line x equals opposite of b over 2a. That gives us that vertical line that'll go through our vertex. Well then, all of you wonderful math students might ask me, well, what about C? I only see A and B. And when I defined my vertex, I only used that generic formula that had A and B, no C in it. But if I take a look at a graph, and so this is the example, the negative 2x squared plus 5x or minus 5x, and I shift it around and I have a different C value, all it changes is the location on the vertical axis. The line for the vertex is the same no matter what that C value is, so C doesn't matter when I'm determining the vertex and the axis of symmetry. So what we're going to do is in your notes, you're going to write down these steps to graph with when we only know the vertex and we can't factor. If I have an A value that's greater than 0, my parabola is going to face up. It'll be U-shaped. If A is less than 0, if it's a negative number, let's see, there we go, it's going to be downwards. It's going to be N-shaped. So then my axis of symmetry is going to be at that line where x equals the opposite of b over 2a, and I will use that x value for my vertex to find my y value, and I'll plot my vertex. Then I will use my y-intercept, which will be that c value. Remember, if I don't have a given c value, I know that it's 0. So let's practice with this skill here. First thing I want to do is if I look at this one here, I can't graph it using my factoring method. I want to find that axis of symmetry. So I know that the x value for my vertex is going to be the opposite of b over 2a. And I see in my equation here, I have that a value. Let's use lowercase. I have my a value. It's invisible. It was a 1. I have a b value, and I have a c value. So my vertex, the x value for my vertex is going to be the opposite of 2 over 2 times my a value of 1. So the opposite of 2 over positive 2, let's see, that gives us an x value, where's my green, there we go, is going to be at negative 1. So I'm going to put in that dotted line through negative 1. Now to find my y value for my vertex, I plug negative 1 back in, and I get negative 1 squared plus 2 times the negative 1 plus 5. Well, that gives me 1 minus 2 plus 5, which gives me 4. So I know that my vertex is going to be located at negative 1, positive 4. My parabola is going to face upwards. I know that this is true because I see that a value is a positive number. And that makes sense because my y-intercept is going to be located at the point 0, 5, right there. And I can use my reflection to find one more point here. If I reflect across that axis of symmetry, I have my 3 points, and my graph will look like, approximately, like this. Let's go back in and make sure I have exact answers written out. So my axis of symmetry is going to look like the line x equals negative 1, that vertical line through my axis of symmetry. The point for my vertex is going to be my x value of negative 1. When I plugged it back in, I found a y value of 4. My y-intercept is 0c, and then I know it's going to be U-shaped because the a value is positive. If I tap this in on Desmos, I find out that yes, it does look like this here. That vertex is at negative 1, 4. My y-intercept is at 0, 5, and then if I reflect it across, I find the point negative 2, 5. And I can use those 3 points to sketch my parabola. Well, let's try it again with another one here. This time I have 2x squared plus 4x plus 3. Again, for my axis of symmetry, I'm going to use that idea of the vertex. The x value of my vertex is going to be located at the opposite of b over 2a. And if I look at my pieces, again, I have my a, b, and c. I have the opposite of 4 over 2 times 2. Well, again, this time, the x value of my vertex is at -1. So the equation for my vertex line is going to be x equals -1. That dotted line that goes straight through this part here. To find the vertex itself, well, now I need to take that x value of -1 and plug it in. So I get 2 times -1 squared plus 4 times a -1 plus 3. Well, -1 squared is +1 times 2 is 2. 4 times -1 is -4 plus 3. And if I go through my steps here, I get a value of 1. Vy is 1. So my ordered pair is going to look like, let's see, let's squish it in right here. I have -1, +1. My y-intercept, well, that's going to be my c value, so my y-intercept is 0, 3. And my shape is again going to be U-shaped because I see that my a value is positive. So if I plot these points here, I have my vertex at -1, +1, right there, approximately. I have a y-intercept at 0, 3. And then if I reflect across the line, I land at -2, +3. And now it's time to draw in that sketch of my U-shaped curve. And with Desmos, again, the same values here, much prettier graph. My vertex is at -1, +1. My y-intercept is 0, 3. And I can reflect across that line of symmetry to find one more point at -2, +3. So your job tonight is to work on the worksheet. If you were in class on Friday, you received a copy of it. Otherwise, you can find the PDF on Teams. Your job, by the time I see you, if you're coming to class on Thursday, is you should have the worksheet from 8.7b finished. You should have this worksheet finished, and you should have the first 8 skills on the Delta Math finished. Some of them are pretty quick. They ask you to review your fraction skills, and then some of them are a little more complicated, where you're going to be using this idea of finding the vertex and line of symmetry. So, lots to keep you busy. Your job, so if you're trying to space out your work here, Monday, you should be watching the video and taking notes. Tuesday, you should be finishing up this worksheet, and then Wednesday, I suggest you work on Delta Math. Make sure that you're sending me messages if you have questions. Otherwise, I will see you on Thursday. Thanks, guys.